Hi, amazing morning everyone. This is Sharni Yamomo Ginano, and I'll be reporting the second part of our report in this chapter, Chapter 9, Differential Analysis and Product Pricing. So to start with, let us have a recap first. In this chapter, differential analysis is illustrated for the following common decisions. First, leasing or selling equipment. Second, discontinuing an unprofitable segment. Third, manufacturing or purchasing a needed part. Fourth, replacing fixed assets. Fifth, selling a product or processing further. And the last one, accepting additional business at a special price. And since the first four has been discussed already, so let me start to discuss with you the process or sell and accept business at a special price and differential analysis. Also, let me discuss with you the product cost concept, target costing, and production bottlenecks. Process or sell. The sell or process further decision is the choice of selling a product now or processing it further to earn additional revenue. During manufacturing, a product normally progresses through various stages or processes. In some cases, a product can be sold at an intermediate stage of production, or it can be processed further and then sold. Differential analysis can be used to decide whether to sell a product at an intermediate stage or to process it further. In doing so, the differential revenues and cost from further processing are compared. The cost of producing the intermediate product do not change, regardless of whether the intermediate product is sold or processed further. To illustrate, assume that a business produces kerosene as an intermediate product as follows. If this is to be sold, the batch size of kerosene produces 4,000 gallons, and the cost of producing kerosene is $2,400 per batch, with a selling price of $2.50 per gallon. On the other hand, if it has to be processed further, the kerosene can be processed and yield gasoline as follows. The input size per batch is 4,000 gallons, less the evaporation 800 gallons, which is 20% of the 4,000. Therefore, the output batch size is equals to 3,200 gallons. And the cost of producing gasoline is $3,050 per batch, with a selling price of $3.50 per gallon. As shown in this table, differential analysis dated October 1 for whether to sell kerosene as alternative 1 or process it further into gasoline as alternative 2. As shown in the third column, under differential effect on income, there is additional income of $550 per batch from further processing the kerosene into gasoline. Therefore, the decision should be to process the kerosene further into gasoline. Next is accept business at special price, the last part of differential analysis. A company may be offered the opportunity to sell its products at prices other than normal prices. For example, an exporter may offer to sell a company's products overseas at special discount prices. Differential analysis can be used to decide whether to accept that offer at a special price. The differential revenue from accepting the additional business is compared to the differential costs of producing and delivering the product to the customer. The differential cost of accepting additional business depend on whether the company is operating at less than capacity. If the company is operating at less than full capacity, then the additional production does not increase fixed manufacturing costs. However, selling and administrative expenses may change because of the additional business. For example, assume that B-Ball Incorporated manufactures basketballs with the following data. Its monthly productive capacity is 12,500 basketballs. Current monthly sales 10,000 basketballs. The normal domestic selling price is $30 per basketball, and the total manufacturing cost is $20 per basketball, and that consists of variable cost of $12.50 per basketball and fixed cost of $7.50. So on March 10 of the current year, B-Ball Incorporated received an offer from an exporter for 5,000 basketballs at $18 each. Production can be spread over 3 months without interfering with normal production or incurring overtime costs. Pricing policies in the domestic market will not be affected. So the question is, should B-Ball Incorporated has to reject or accept the offer? As shown in this table, a differential analysis on whether to reject the order, which is the alternative 1, or accept the order, or the alternative 2, shows that the special order should be accepted. The special business is accepted even though the sales price of $18 per unit is less than the manufacturing cost of $20 per unit, because the fixed costs are not affected by the decision and are thus omitted from the analysis. Setting normal product selling prices. The normal selling price is the target selling price to be achieved in the long term. The normal selling price must be set high enough to cover all costs and expenses, such as the fixed and variable costs, and provide a reasonable profit. Otherwise, the business will not survive. In contrast, in deciding whether to accept additional business at a special price, only differential costs are considered. Any price greater than the differential costs will increase profits in the short term. However, in the long term, products are sold at normal prices rather than special prices. Managers then can use one of two market methods to determine the selling price, which is the demand-based concept or the competition-based concept. The demand-based concept sets the price according to the demand for the product. If there is high demand for the product, then the price is set high. Likewise, if there is a low demand for the product, then the price is set low. On the other hand, the competition-based concept sets the price according to the price offered by the competitors. For example, if a competitor reduces the price, then management adjusts the price to meet the competition. The market-based pricing approaches are usually discussed in details in marketing courses. In addition, manager can also use one of three cost-plus methods to determine the selling price, which is the product cost concept, total cost concept, or the variable cost concept. Cost-plus methods determines the normal selling price by estimating a cost amount per unit and adding a markup. Management determines the markup based on the desired profit for the product. The markup should be sufficient to earn the desired profit plus cover any costs and expenses that are not included in the cost amount. So the question is, what is product cost concept and how it is applied? Under this concept, only the costs of manufacturing the product, termed the product costs, are included in the cost amount per unit, to which the markup is added. Estimated selling expenses, administrative expenses, and desired profit are included in the markup. The markup per unit is then computed and added to the product cost per unit to determine the normal selling price. The product cost concept is applied using the following steps. Step 1. Estimate the total product costs as follows. Direct materials plus direct labor plus factory overhead is equals to total product cost. Step 2. Estimate the total selling and administrative expenses. Step 3. Divide the total product costs by the number of units expected to be produced and sold to determine the total product cost per unit. Or product cost per unit is equals to total product cost divided by estimated units produced and sold. Step 4. Compute the markup percentage as follows. Markup percentage is equals to desired profit plus total selling and administrative expenses divided by the total product cost. The numerator of the markup percentage is the desired profit plus the total selling and administrative expenses. These expenses must be included in the markup percentage because they are not included in the cost amount to which the markup is added. The desired profit is normally computed based on a rate of return on assets as follows. Desired profit is equals desired rate of return times total assets. Step 5. Determine the markup per unit by multiplying the markup percentage times the product cost per unit as follows. Markup per unit is equals markup percentage times product cost per unit. Step 6. Determine the normal selling price by adding the markup per unit to the product cost per unit as follows. Product cost per unit plus markup per unit is equals to normal selling price per unit. To illustrate the product cost concept application, Let us assume the following data for 100,000 calculators that Digital Solution Incorporated expect to produce and sell during the current year. Manufacturing costs are direct materials, $3 times 100,000 calculators is equals to $300,000. For direct labor, $10 times 100,000 calculators is equals to $1 million. And for the factory overhead equals $200,000 with a total manufacturing costs of $1,500,000 plus the selling and administrative expenses $170,000 with a total cost of $1,670,000. Total assets $800,000 and the desired rate of return is 20%. The normal selling price of $18.30 is determined under the product cost concept as follows. Step 1. Total product cost is equals to $1,500,000. Step 2. Total selling and administrative expenses is equals to $170,000. Step 3. Total product cost per unit is equals to $15. To compute total product cost of $1,500,000 divided by the estimated unit produced and sold, which is 100,000 units of calculators, is equals to $15 per unit. Step 4. How much is the markup percentage? In order to get the markup percentage, let us get first or solve the desired profit using the desired rate of return times total assets, which is rate of return is 20% times $800,000 total assets is equals to $160,000. Then, let us compute the markup percentage by adding the desired profit, which is the $160,000 plus total selling and administrative expenses worth $170,000 divided by the total product costs of $1,500,000, and that is equals to 22%. Step 5. How much is the markup per unit? In order to get the markup per unit, let us multiply the markup percentage or the result from step 4, which is 22%, times the product cost per unit or the result from step 3, which is the $15. So 22% times $15 is equals to 3.30 per unit, and that is the markup per unit. Step 6. Normal selling price is $18.30, which is composed of total product cost per unit, $15, plus markup per unit is equals to $3.30. Product cost estimates rather than actual cost may be used in computing the markup. Management should be careful, however, when using estimated or standard cost in applying the cost-plus approach. Specifically, estimates should be based on normal or attainable operating levels and not theoretical or the ideal levels of performance. In product pricing, the use of estimates based on ideal operating performance could lead to setting product price too low. Target costing and the product cost concept is a method of setting prices that combines market-based pricing with cost reduction emphasis. Under target costing, a future selling price is anticipated using the demand-based or the competition-based concepts. The target cost is then determined by subtracting a desired profit from the expected selling price, or computed as target cost is equals to expected selling price minus the desired profit. Target costing tries to reduce cost as shown in Exhibit 10. The bar at the left in Exhibit 10 shows the actual cost and profit that can be earned during the current period. The bar at the right shows that the market price is expected to decline in the future. The target cost is estimated at the difference between the expected market price and the desired profit. The target cost is normally less than the current cost. Thus, manager must try to reduce costs from the design and manufacture of the product. The planned cost reduction is sometimes referred to as the cost drift. Cost can be reduced in a variety of ways, such as simplifying the design, reducing the cost of direct materials, reducing the direct labor costs, or eliminating waste. Target costing is especially useful in highly competitive markets such as the market for personal computers. Such markets require continual product cost reductions to remain competitive. Production bottlenecks. A production bottleneck or constraint is a point in the manufacturing process where the demand for the company's product exceeds the ability to produce the product. The theory of constraints, or TOC, is a manufacturing strategy that focuses on reducing the influence of bottlenecks on production processes. When a company has a production bottleneck in its production process, it should attempt to maximize its profits, subject to the production bottleneck. In doing so, the unit contribution margin of each product per production bottleneck constraint is used. To illustrate, assume that Brightcraft Tool Company makes three types of wrenches: the small, medium, and large wrenches. All three products are processed through a heat treatment operation, which hardens the steel tools. Brightcraft Tools' heat treatment process is operating at full capacity and is a production bottleneck. The product unit contribution margin and the number of hours of heat treatment used by each type of wrench are as follows: unit selling price, unit variable cost, and the total unit contribution margin, heat treatment hours per unit, according to each column. Heat treatment hours per unit for a small wrench is 1 hour, for medium wrench 4 hours, for the large wrench 8 hours, and the total contribution margin per wrenches is $90 for a small wrench, medium wrench $100, and for the large wrench is $120. The large wrench appears to be the most profitable product because its unit contribution margin of 120 is the greatest. However, the unit contribution margin can be misleading in a production bottleneck operation. In a production bottleneck operation, the best measure of profitability is the unit contribution margin per production bottleneck constraint. For Pride Graph tool, the production bottleneck constraint is heat treatment process hours. Therefore, the unit contribution margin per bottleneck constraint is expressed as follows. Unit contribution margin per production bottleneck hour is equals to unit contribution margin divided by heat treatment hours per unit. The unit contribution per production bottleneck hour for each of the wrenches are then computed as follows. For small wrenches, unit contribution margin per production bottleneck hour is equals to $90 divided by 1 hour is equals to 90 per hour. For medium wrenches, $100 divided by 4 hours is equals to 25 per hour. For the large wrenches, unit contribution margin per production bottleneck hour is equals to $120 divided by 8 hours is equals $15 per hour. The small wrench produces the highest unit contribution margin per production bottleneck hour, which is the heat treatment of $90 per hour. In contrast, the large wrench has the largest contribution margin per unit of $120, but has the smallest unit contribution margin per production bottleneck hour of $15 per hour. Thus, the small wrench is the most profitable product per production bottleneck hour and is the one that should be emphasized in the market. Total cost concept. Under this concept, manufacturing cost plus the selling and administrative expenses are included in the total cost per unit. The markup per unit is then computed and added to the total cost per unit to determine the normal selling price. The total cost concept is applied using the following steps. Step 1. Estimate the total manufacturing cost as follows. Direct materials plus direct labor plus factory overhead is equals to total manufacturing cost. Step 2. Estimate the total selling and administrative expenses. Step 3. Estimate the total cost as follows. Total manufacturing costs plus selling and administrative expenses is equals to total cost. Step 4. Divide the total cost by the number of units expected to be produced and sold to determine the total cost per unit, or total cost per unit is equals to total cost divided by estimated units produced and sold. Step 5. Compute the markup percentage as follows. Markup percentage is equals to desired profit or total cost. The desired profit is normally computed based on a rate of return on assets as follows. Desired profit is equals to desired rate of return times total assets. Step 6. Determine the markup per unit by multiplying the markup percentage times the total cost per unit, or markup per unit is equals to markup percentage times total cost per unit. Step 7. Determine the normal selling price by adding the markup per unit to the total cost per unit, or total cost per unit plus markup per unit is equals to normal selling price per unit. Example. Let us assume that the data below are for the production of 100,000 calculators of digital solutions that are expected to produce and sell during 2016. The normal selling price of $18.30 is determined as follows. Step 1. The total manufacturing cost of $1,500,000. Step 2. Total selling and administrative expenses is $170,000. Step 3. Total cost is $1,670,000. Step 4. How much is the total cost per unit? Total cost per unit is equals to 16.70, that is coming from total cost of $1,670,000 divided by the estimated units produced and sold, which is 100,000 units. Step 5. The markup percentage is equals to 9.6. In order to get it, let us first solve the desired profit, which is desired rate of return of 20% times the total assets of $800,000 is equals to $160,000. Then, let us proceed to the markup percentage, that is equals to the desired profit of $160,000 divided by the total cost of $1,670,000 is equals to 9.6%. Step 6. Markup per unit is equals to 1.60. In order to get, let us multiply the markup percentage of 9.6 times the total cost per unit, which is $16.70, and that is equals to $1.60 per unit. Step 7. The normal selling price is equals to 18.30, which is composed of the total cost per unit, that is $16.70, plus markup per unit of $1.60. Total to selling price per unit is equals $18.30. The ability of the selling price of $18.30 to generate the desired profit of $160,000 is illustrated by the income statement as shown below. The total cost concept is often used by contractors who sell products to government agencies. This is because, in many cases, government contractors are required by law to be reimbursed for their products on a total cost plus profit basis. The last but not the least is the variable cost concept. Under this concept, only variable costs are included in the cost amount per unit to which the markup is added. All variable manufacturing costs, as well as variable selling and administrative expenses, are included in the cost amount. Fixed manufacturing costs, fixed selling and administrative expenses, and desired profit are included in the markup. The markup per unit is then added to the variable cost per unit to determine the normal selling price. The variable cost concept is applied using the following steps. Step 1. Estimate the total variable product cost as follows. Direct materials plus direct labor plus variable factory overhead is equals to total variable product cost. Step 2. Estimate the total variable selling and administrative expenses. Step 3. Determine the total variable cost as follows. Total variable product cost plus total variable selling and administrative expenses is equals total variable cost. Step 4. Compute the variable cost per unit as follows. Variable cost per unit is equals to total variable cost divided by estimated units produced and sold. Step 5. Compute the markup percentage as follows. Markup percentage is equals desired profit plus total fixed costs and expenses divided by the total variable cost. The desired profit is normally computed based on a rate of return on assets as follows. Desired profit is equals desired rate of return times total assets. Step 6. Determine the markup per unit by multiplying the markup percentage times the variable cost per unit as follows. Markup per unit is equals to markup percentage times variable cost per unit. Step 7. Determine the normal selling price by adding the markup per unit to the variable cost per unit as follows. Variable cost per unit plus markup per unit is equals to normal selling price per unit. To illustrate, let us assume the same data for the production and sale of 100,000 calculators by Digital Solutions Incorporated, as in the preceding example. The normal selling price of $18.30 is determined under the variable cost concept as follows. Step 1. The total variable product cost is equals to $1,450,000, which is composed of direct materials, $300,000, direct labor, $1 million, plus variable factory overhead, $150,000, and total of $1,450,000. Step 2. Total variable selling and administrative expenses is equals to $150,000. Step 3. Total variable cost is equals to $1,600,000. Step 4. Variable cost per unit is equals to $16. Step 5. Markup percentage is equals to 14.4%. In order to get it, let us solve first the desired profit, which is desired rate of return of 20% times the total assets of $800,000, that is equals $160,000. Then let us solve the markup percentage. The desired profit of $160,000 plus the total fixed costs and expenses of $70,000 divided by the total variable cost of $1,600,000 is equals to 14.4%. Step 6. Markup per unit is equals to $2.30. That is markup percentage of 14.4 times the variable cost per unit of $16 is equals to $2.30 per unit. Step 7. The normal selling price is equals to $18.30, and that is total variable cost per unit of $16 plus markup per unit of $2.30 is equals to normal selling price per unit of $18.30. So that's the end of my report. Thank you very much for your time. Once again, this is Sharni Ginano. Have a great day.